Yeah, thanks for coming. So it will be a short talk, frankly. It's like a lightning talk, 25 minutes, very practical, nothing crazy. And yeah, we're talking about how to add security layer to your APIs and apps in the cloud-native environments, primarily in the Kubernetes. So how many of you folks use NGINX in your environments? Okay, half. How many of you use Kubernetes now? Not too many. I bet the next year will be much more. But anyway, so we have a tight agenda here. I try to make this talk very practical, so we can have a lot of takeaways right away. But first, let's talk about NGINX. So why we're talking about the NGINX. So the thing is that you already have NGINX in your infrastructure. I mean, most of you already have it as a load balancer or as a web server, and your traffic is already analyzed with the NGINX. And the good thing that NGINX is also the foundation for the Kubernetes ingress controller. So basically, if you use an ingress controller, you also use the NGINX, and you can use all the capabilities. And another thing, that NGINX can be easily deployed as a sidecar in every Kubernetes pod. So basically, you can add NGINX natively in any application pod, which is very nice. So this is just the standard way how you usually put the NGINX with your apps. And basically, you can put WAF and any other modules there. So for those who don't know what is NGINX, so it's a very popular web server that is very scalable, which is very good, but it's also very easy to customize and very easy to enhance with different kind of plugins. As I said, the NGINX is also the part of the ingress controller. So basically, if you're using Kubernetes and you have ingress, you have all the traffic coming through the ingress controller. And this is a perfect spot where you can add the security layer. And as I said, you can also deploy the NGINX as a sidecar in every application pod, which is once again very good, because you can add this NGINX with the security modules to pretty much every microservice you already have. Let's start with the how to set up the WAF for the Kubernetes environment. So basically, if you're using the NGINX, it's very easy to use, just the regular NGINX without Kubernetes. It's very easy to use. You just go to the config file, add some directives there, mod security enabled, and you get the mod security on in your environment. With the ingress and with the Kubernetes, it's almost the same. So you just use the config map. So this is the file where you can actually can add it and configure the ingress controller. So basically, you just need to add a few more modules there. So as you can see on this slide, enable mod security true, enable OWASP mod security CRS true. So and this is pretty much it. You also can add some additional data here, and for instance, where you want to put the audit files, this is important, and I will tell you later why it's very important. So basically, if you do this, you have the WAF deployed in your Kubernetes environment already. So you can send the curl command with some malicious payload, a SQL injection here, and you get 403. It means that the request was blocked. So it's very easy. So what we do next is build a kind of dashboard to get some visibility of what is happening, and also to set up. It also set up a kind of alerting, so to know what is happening in real time. The setup is very basic, actually. So once again, you have this Kubernetes environment, and you have NGINX. You can have just the NGINX, so it's Kubernetes not a requirement. We will get all the log files with the fluentd. You can use logstash. For the logstash, you already have the module as well. And basically, the fluentd will get all the logs from the NGINX mod security, put into the Elasticsearch. Then we'll use Kibana to make a kind of dashboard. And then we use the last alert, so this is a project by Yelp, to send you real-time notifications to Slack or email. I will cover it later. So the setup is very basic. So we store all the logs in your some log files in the ingress controller. So fluentd is basically the special daemon which will analyze and parse all the logs. And then the Fluent sends all the logs to the Elasticsearch. With the Kibana, you just make the different kind of dashboards or different kind of search queries. It's very easy to do. And then you set up the alerting. So fluentd, the best way to run it is to run it as a sidecar in the ingress NGINX pod. And what is good to do here to make the thing simple is to share a volume
between the ingress NGINX and the FluentD. So in this case, the FluentD can access the mod security logs. This is just like, I don't want to go through this, so it's very simple, but this will be in the slide, so you can set up everything in your environment, so it's very easy. After that, if you set up everything, you can open the Elasticsearch UI, and you will see that there are like all the events from your mod security about all the attacks with some details there. You already have in Elasticsearch. You can like set up Kibana, and like I don't want to go through all the deployment and setup. It's very easy. You can run it from the Docker now with the predefined values. But basically, you can like set up different kind of dashboards and have stats on like how many attacks you see, how many SQL injection requests, where the application responds with the like 500 error codes, something like that. It's pretty cool to put on the TV screen somewhere in the office. But pretty much soon you will understand that, okay, dashboard is nice to have, but like I don't really want to look at this dashboard. I want to know when something wrong is happening. So and this is where you need to set up a kind of alerts. So the next thing is like how to set up the alerts. And once again, it's very easy. And the reason why it's so easy is because we have this a very good project by the company called Yelp. I'm pretty sure you know the Yelp. And the project is called Elast Alert. It's open source, and what it does actually, it just takes all the events from the Elasticsearch and can send the alerts to whatever you use. So basically, you can, if you have some data in Kibana, you can make the alert and send notifications. So for instance, you can have the alerts when something is matching like at least X events in Y time, or if there's a rate of events increases or decreases, like all the different kinds of criteria you can use here. So it's very scalable, and you will soon understand how powerful this mechanism is actually. You can send the alerts to your email, to Jira. You can send it to different kind of messaging apps like HipChat or Slack or Telegram. You can send it to PagerDuty, Opsgenie, or whatever other tools you're using. So it's very scalable. The good thing is like it's very easy to set up as well. So you basically just like creating the trigger, like I call it WAF trigger now, and as you see, we're using the data from the mod security. We're taking the data within the 10 minutes time frame. We're using some filters to give the Elast alert to understand when we need to send the notification. And this is what is happening when the trigger happens. So we're saying, hey, we want to send a Slack chat, like Slack message. So basically put here the details of this Slack bot, like the name of it, and then we're sending the notification, like by saying, hey, the CRS rule happens here, and the host and the path is in this. So it's very easy to do. So eventually you will see different kind of alerts just in your Slack. So it's super scalable way how you can get a real-time understanding of what is happening, and you don't need to go to the dashboards, which is pretty much cool. The next thing I want to cover is the situation when you want to deploy WAF or any other tool, but like somebody from your team is saying, hey, I don't want any security in place because it will break the apps. So let's try it out first and be sure that it's safe. So in these ways, you can mirror the traffic. And the idea is that you set up a kind of additional backend with the WAF, for instance, and you send the copy of each request to this additional backend from your load balancer for the NGINX. And thankfully, NGINX a year and a half ago introduced this capability, which is called Miro. So basically, you can say that I want to mirror all the requests that come to this location, and you setting up this mirror location. So it's very easy to set up. What happens after that is that every request will come to the your main backend, to your app basically, but also the copy of this request will go to the WAF, and it will be analyzed, and there is no chance that it can anyhow affect the traffic, which is pretty much awesome. We do a lot of POCs with using this kind of stuff because customers don't want to break the apps, especially during the POC. Speaking about WAF, by the way, so If we're using for the web for the NGINX, you basically have a choice of the some open source tools and commercial products. Speaking about the open source tools, like obviously you have mod security, we mentioned it today, and you have NGINX. This is the web specifically written for the for the NGINX. I will cover it later. From a commercial side, there's a kind of NG web products like WallArm, where I'm one of the co-founders. Another product is Signal Sciences, and it's, by the way, developed here in LA. So I'll cover it a little bit in more detail. So mod security is very fast. I pretty know that you know everything about the ModSec, so I don't want to cover it a lot. But basically, what is very nice about the mod security is that you can set up different kind of rules to analyze the request and also to analyze the response. And this gives a lot of capabilities. But the pain in the neck here is the false positives. So unfortunately, you need to deal with a huge number of the false positives. And there are some best practices here. So one of them is actually to use the public rule set only in monitoring mode. And if you really want to use it in a blocking mode, you can set up this the security rules from scratch for you. So basically, you can say I want to analyze the request and see if there is a payload like this, and only if there is a response like this, consider this as an attack. So there are a lot of hacks, and I recommend you to read this mod security handbook. It's one of the best one if you want to know how to really tune the mod security. Another thing I found a very nice approach to try is that to try the method by the Christian Fellini. So this guy, what he basically does here, grab all the mod security log files, and then he run a basic statistics on all the events and see how many events are within this certain threshold. And this is the way, a very a very straightforward way how you can step by step reduce the false positives for every particular app. So you can read all the details using this link. The bad thing is this process is kind of painful and it's endless. When you will update the app, you probably will need to, in the worst case, you will need to do this once again, and this is not cool. So the NGINX, this product is not that popular as the mod security, but basically the good thing about the NGINX is that it doesn't use signatures, it doesn't use regular expressions, it uses a kind of tokens. So basically, if you have this SQL injection, SQL operators like select, union, update, and the NGINX sees those keywords in the traffic, it increases the score of the request, and eventually, if the score is more than some particular threshold, it considers this request to be malicious. So NGINX rules looks like this. It's pretty scary, but you don't need to tune them. What you need to tune is a kind of whitelist. So unfortunately, the false positives is also a case for the NGINX. But the good thing here is that NGINX comes with a special tool which allow you to analyze all the traffic and create a kind of whitelist. So you don't need to tune the rules manually. You just turn this tool, then run the traffic, and the NGINX will create the whitelist for you, which is pretty much awesome. Speaking about the commercial webs, so I don't want to make this a lot of advertising here, so just a few words about what we do. So we do the NG WAF, and we also do the desk scanner. And the way we do WAF is that we are not using any signatures. We use machine learning to identify what is the structure of your app, so we can create the rules specifically for every particular app and the microservice you have. And we also use neural networks to analyze all the attacks you have to identify if you have any false positives. So there are a lot of other techniques like the grammar analysis, and not using any signatures in place. But eventually you see what is the app structure you have, so you don't need to do this manually. And you see all the events in a very nice UI. So if you want to try it out, come to our booth or just leave a request and we show it down for you. The next thing I want to cover is the behavioral-based security. So eventually, if you set up a process, you will get a lot of sources of the data, like the WAF, and then some kind of feeds, and then you have some threat intelligence feed. So you want to kind of way how you can correlate all those data in one place. And the open source project called Rapsheet is actually one of the most good ones. So what basically it allows to do is to get all the sources, like the data from the mod security or other WAF, or the some external feeds or whatever you have, and you kind of combine it in one place. Let me show you a demo. So you have all the requests, and then they analyze with a set of the tools you have, and then all the events are correlated in the Redis datasheet, and it basically, this data is basically used to make a decision if this request is malicious or not. So this is just a great framework how we can correlate a lot of feeds in the one place. And once again, this rep sheet thing is developed for the NGINX, so it's very easy to connect there. The last chapter here is how to protect your bots, not bots, but your apps against all kind of bots and behavioral-based attacks. So unfortunately, bots are it's very hard to compete with bots nowadays. So it's always the cat and mice game. So we can put some protection in place, but the scrappers, they will try to overcome it. But there are a bunch of things that you can do easily. So speaking about the bots, what I'm saying, it's application level denial of service attacks, it's site scrapping, it's a different kind of abuse of your APIs and apps, a different kind of brute force, credential stuffing attacks. So I'm pretty sure you know all of this stuff. So one of the things you can try is to use the so-called test cookie module. What is it? It's a special module that is specifically developed to protect your apps against bots. So unfortunately, it doesn't work against the APIs because it's for the APIs because it is the active approach. So the way test cookie works is it runs a different kind of straightforward checks. If the client supports cookies, if the client supports redirect, if the client supports JavaScript, or I don't like this check, but if the client supports Flash, and there's a special cryptography way how you can do that. It's a very nice way. It's a kind of proof of work. So we basically ask the client to execute some kind of task, and if you see that the client is smart enough and it can do all the redirects, JavaScript, there's a chance it's a real user. So unfortunately nowadays, a lot of bots are so-called the full browser stack. So with the Chrome, which is detached, with the Selenium tools, with the full JavaScript engine inside, it's so easy to develop more complicated bots. But you will be surprised how many dumb bots are out there. So in many cases, you can use this test cookie thing to protect. Unfortunately, the project is not maintained anymore, but we tried it recently with one of the customer, and it works. And you also can take the source code and develop everything in Lua, for instance, or JavaScript for the NGINX. So the most important part is the idea how we can do that. One of the things that you also can try to do, and it's fairly easy right now, is to apply machine learning in neural networks to your log files, and you will be surprised how easy it is. So the approach is very easy. If you can identify some malicious requests by your eyes, it's pretty much possible to train the machine learning to identify all those requests. And basically, if you see the bad requests and good requests, you can make the supervised learning thing. I don't want to cover what are the methods and the strategies. There are a lot of publications about that. But I want to give you a link to this kind of proof of concept by a guy who works for the Dropbox, I think. So this is the link. So basically, this is the source code of the neural network that can analyze the access log and identify which of the requests are anomalies. So this is something that you can easily use. The good thing here is that if you have the traffic with no attacks inside, I know that it's pretty much impossible nowadays, but it just will help you to train the neural network much more easily. The next thing is to block those clients that you don't want to see. So, and basically, you can start with the blocking some particular countries. I don't like this method, but if you definitely sure you don't want any users connecting from some particular countries, you can use our GeoIP module. The bad thing that most of the feeds are not accurate, especially the free ones. So, if you really want to use it, it's better to find a commercial feed. what you can block, and in many cases it can be very helpful, is the IP ranges of different cloud and hosting providers, because we see that like a lot of scripts, a lot of bots are really hosted in the very same places where we host our apps. And the good thing is, like the Google Cloud and the AWS and the Azure, they all have the public feeds with all their IP ranges, so you can take just there. And basically you can Google, like you put the name of the hosting company, IP ranges, and there is a good chance that it will be publicly available. So we'll get the list like this, or I think it's Amazon. Yeah, it's Amazon. So basically I'll have all the IP prefixes, and you know if the request is coming from the Amazon, and in many cases it's an anomaly. You can also block everything that comes from Tor. In the Tor exits nodes, like the information about them is public. However, it's not 100% accurate, like and up to date if you go to the official Tor website, but there are some companies that provide more up-to-date data. There are some data about the IP addresses that are kind of malicious, so that are proxies, anonymizers, and the MaxMine. This is the commercial fee, so it's not free of charge, but you can pay for it. And I'm pretty sure that a lot of you know this, like very old project called Project Honeypot, so where you basically can get the list of a kind of like malicious IPs there. One of the last tips here today is what to do if you see that there is a DDoS attack coming and you can't do, you need temporarily to stop it. So in most cases, the only way is actually to find what is under attack, and like the DDoSers, they will always try to find the most resource intensive application endpoint, like search, for instance. And I don't know, this is the worst thing to do, but sometimes this is the only thing you need to you can do is temporarily disable some application endpoint. And if it's very hard to do it within the app, you can do it with the NGINX, and the NGINX supports a special code. It's called 444. And what's interesting about it is it instantly closes connection and returns nothing. So it's very efficient way how we can block all the requests. And you also will get all the data about those requests in your log files. So you can easily block them with the, not AppSec, but IPSec, IPSec command. So we basically grab the access log, find everything with the 404 code there, and just block it. And that was supposed the last slide, but I have actually one more. So we're speaking about the DDoS. And there are a lot of things, like the NGINX is very scalable, and it's very fast, but every source has its limit. So basically, you need to understand what is the limit and scale accordingly. NGINX supports a lot of ways how you can tune it. So you can limit the buffers, and you see there's limitations for the headers, for the body, so we can limit all those stuff. And you also can limit the timeouts, actually. So there are a lot of directives within the NGINX that can help you to set up the timeouts for the connections and so forth. So if you have, it's not only related to the DDoS, it's also related, if you're DevOps, DevSecOps, it's always good to know what directives and what tools you have to tune the performance of the NGINX. Unfortunately, there is no way, I want to say this is the way how you can set up the ideals or values for all those things, but it's, there is not such a way. So it's days of work to identify which works for your app and which is not working. And it's 25 minutes, so I'm just right in time. So thanks everyone to coming. Hope that some of those tips were helpful. And if you have any questions, feel free to ask. We have a booth here, Wallen booth, so come by and say hi to our folks.
Are you posting the slides somewhere?
Yeah, I'll share it in our Twitter.
All right, awesome. It's definitely a lightning talk.
Are there any other questions? I can bring the mic over to you if you have any questions. Okay.
Okay, thank you.
Thank you very much.
Thanks.
Stefan.